Hi, everyone. Welcome back. And today we are going to start talking about elementary series and also alternating series. So, in this lesson, we're going to learn about the four elementary power series that you're actually expected to know from memory for the AP exam. So, definitely start trying to memorize these now. You can definitely derive them yourself because they really are just Taylor series expansions. All of these are actually Maclaurin series centered at 0, except for natural log of x for obvious reasons. That one's actually centered at 1. But like I said, you can derive these yourself, but it really does help to memorize these for the AP exam. Okay, so sine of x, we actually did this one in a previous lesson, but it starts out with x minus, and we get all the odd powers of x. So we have x cubed over 3 factorial plus, and it alternates, right? X to the 5th over 5 factorial plus or minus dot dot dot, and we'll go ahead and write in our general term. Remember, this alternates, so we can write this in a number of different ways, but the way I'm going to write it is -1 to the n minus 1 times x to the 2n minus 1 all over 2n minus 1 factorial. And then this is a series, so it would be plus dot dot dot. And so think about the fact that if we index this at 1, it should generate all of the terms that you want. Okay, and so in sigma notation, this would be the sum from n equals 1 to infinity of -1 to the n minus 1 times x to the 2n minus 1 all over 2n minus 1 factorial. All right, cosine of x, this one actually starts out with 1, and then we get all of the even powers of x. So we have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, and then minus dot dot dot. We'll go ahead and write in our general term. Remember, this alternates, so we have -1 we can do to the nth power, times x to the 2n all over 2n factorial. And this works out if we index it starting at 0, it should line up with what we want. So the sum from n equals 0 to infinity of -1 to the nth power times x to the 2n all over 2n factorial. Okay, and then e to the x, we did this one quite a few times now, but this one is just 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus, right? You get the point. So this would be x to the n over n factorial, and that keeps going. And in sigma notation, we can go ahead and index this at 0. The sum from n equals 0 to infinity of x to the nth power over n factorial. Okay, those three are all Maclaurin series. The last one is a Taylor series centered at 1. And so natural log of x, we get our first term as x minus 1 minus x minus 1 squared over 2 factorial plus x minus 1 cubed over, well, it is 2 factorial, but it's because you end up with a cancellation. We derived this one a while back, so it's actually just x minus 1 squared over 2, x minus 1 cubed over 3, oops, minus dot dot dot, and we can do our general term. So remember, this one also alternates, so we'll do -1 to the n minus 1 times x minus 1 to the power of n. Now this one's just over n. And remember, it would keep going. So in sigma notation, we can index this starting at 1 to infinity of -1 to the n minus 1 times x minus 1 to the n all over n. So these four are the only four that you would really need to memorize. Remember, you're not really memorizing it. If you remember the general rule of thumb for finding Maclaurin polynomials / series and Taylor series, you should be okay, and you should be able to derive it if you absolutely need to. Okay, so now utilizing these four elementary functions or series, we're going to find a power series for each of the following functions. So we're going to show four terms in the general term. Okay, so the first one, we're finding sine of x squared, which basically means anywhere I see an x within that series, I'm just going to sub it in with an x squared. So the first term, I'm plugging in x squared for x, so it's just x squared, minus, I'm subbing in x squared cubed, which would be x to the 6th over 3 factorial, plus it would be x squared to the 5th, right, which is x to the 10th over 5 factorial, and it wants the first four terms, so we want to go one more. It would be x to the 7th over 5 factorial, but it's x squared now to the 7th, which is x to the 14th over 7 factorial. Okay, so now we're going to go ahead and write in our general term plus ... Remember, you only have to do it if it asks. Unfortunately, it did ask, so we have to do it. Okay, so we can write this as, be careful, it does alternate. So we have -1 to the, now you kind of want to figure out what the next term's going to be before you decide how to index that -1, because you want to make sure it alternates properly. So we'll do -1. I'm going to leave the exponent as a question mark for just right now. And then we have x to the, now it's 2 times an odd number, right? So x to the 2 times 2n plus 1 should work if we decide to index, let's see, at n equals 0. And so I think, with that being said, let's see, 0, 1, we'll get 6, 2, we'll get 10. Yeah, so that should work. So it looks like because the first one's positive, then negative, we should be able to just raise this to the power of n, and it should alternate the way we want to, since we're starting at n equals 0. Now you can change the way you index it. It doesn't really matter as long as it generates the terms properly. And it would be all over 2n plus 1 factorial, and then plus ... Okay, go ahead and pause here and go ahead and do 2 through 5. So you're just manipulating those power series or elementary series above to go ahead and create new ones. All right, so hopefully I had a chance to go through those. Cosine of root x, meaning I'm taking all of the terms of cosine, and anywhere I see an x, I'm going to replace it with a square root of x. You could also think of it as x to the 1/2, right? So you should have ended up with 1 minus the root x squared is just x over 2 factorial, plus x to the 1/2 to the 4th is x squared over 4 factorial. And then we have one more term, so it's going to be x to the 1/2 to the 6th, which is x to the 3rd over 6 factorial. 2, 4, 6. Okay, plus ... And now it's time to come up with our general term. So if you notice, those factorials are double what your degree is. So keep that in mind. It's also alternating. So once again, I'm not going to deal with this guy yet. I'm going to put a question mark there as a placeholder for the -1. And then we have, it looks like x. And it looks like if I index it starting at 0, it will work. So we'll do x to the n, because then it would be 0, 1, 2, 3 for my powers. And it looks like it's double whatever n is. So we could do 2n factorial, and then plus ... It looks like we could also index -1 or make -1 to the nth power as well, because if I start with 0, we'll get a positive for the first value. Um, and that's it for number 2. Okay, for number 3, all we're doing is we're taking each term of e to the x and we're just multiplying it by x. So it would be 1 times x is just x, plus x times x is x squared, plus x squared times x is x cubed over 2 factorial, plus that fourth term would be x to the fourth over 3 factorial. And then we're going to go ahead. This one's non-alternating, so we don't need to worry about a -1 to the power of something. And so this one will just start with x, and it looks like it's 1, 2, 3, 4, right? So then it's just x to the n. If we index the sum at n equals 1, this works out fine, over, but be careful because your factorial is 1 less than whatever you had your power as. So we're going to do n minus 1 factorial, and that should generate it. Okay, the next one is 1 over x. They threw this one in here because if you know what the derivative of natural log of x is, it is 1 over x. So all you have to do is take the derivative of each of the terms within natural log of x, and you'll get 1 over x. So the derivative of x minus 1 is just 1, minus the derivative of x minus 1 squared would be 2 times x minus 1 over 2, plus we'd end up with 3 times x minus 1 squared over 3, plus the next one would be 4 times x minus 1 cubed over 4, plus ... Now, before we write our general term, let's actually simplify this. Notice these all cancel out. So we have 1 minus x minus 1 plus x minus 1 squared plus x minus 1 cubed. And so now it's really easy to come up with that general term. So it would be x minus 1 to the nth power. Now keep in mind, you'd want to index that from 0 to infinity because you want to generate 1 as your first term. Okay, last one, we are finding the integral from 1 to t of natural log of x, which means I am now integrating each term of natural log, and I'm going to evaluate it from 1 to t. Okay, so what we're going to do here is we're going to start by integrating each term. So the integral of x minus 1, let's see. Okay, integral of x minus 1 is 1/2 x squared minus x, right? Okay, this actually ends up, let's see. Okay, we'll keep going. Minus the integral of x minus 1 squared over 2. Let's see. I think there's an easier way to do this, actually. Okay, hold on. Okay, so what ends up happening, I believe, when you like FOIL everything out, oh, I got it. Okay, so remember, the derivative of natural log of x is 1 over x. And so we're integrating natural log of x from 1 to t. What ends up happening when you plug things in and FOIL everything out, things cancel out. So this one actually ends up being fairly simple. So what ends up happening is the x minus 1s are going to cancel, I guess, and you're kind of just left with all of the other terms, but subbing in t for x. So you actually end up with t, minus 1 squared over 2 minus t minus 1 cubed over 6 plus t minus 1 to the 4th over 12 minus, and I really did not give you guys enough room to like fully do this one. You would end up with this if you actually integrated each of the terms and then simplified everything through once you plugged in from t to 1. And notice all of your terms, when you plug in 1, go away. So it would just be those first terms. And then we have -1 to the n minus 1 to index it. We'll start with a positive first times t minus 1 to the n plus 1 all over n times n plus 1. And so this is the integral from 1 to t of natural log of x dx. Like I said, I did not give you guys nearly enough room to actually do all of this on this page, but you could really just integrate each of those terms, right? First 4 terms, actually really 5, evaluate it from 1 to t, clean it up, and you end up with this. Okay, so let's move on to alternating series test for convergence. And so essentially what we're doing here is we are looking at series whose terms alternate, and we're going to be able to actually test to see if they converge or diverge using a couple of initial conditions that need to be required first. So an alternating series is a series whose terms alternate, surprisingly enough, between positive and negative. And we've seen 3 of the 4 elementary series that we cover actually are alternating series. Okay, alternating series test for convergence. We're gonna let a sub n be greater than 0. So it means all, so for your general rule, we are gonna kind of look at the non-alternating values, okay? So the alternating series which is the sum from n equals 1 to infinity of -1 to the nth times a sub n. Notice that a sub n is the non-alternating part of this series, right? And the sum from n equals 1 to infinity of -1 to the n plus 1 of a sub n. So it doesn't matter basically what this is saying if the first term is positive or negative, doesn't matter. Converge if, now notice this test only tests convergence. So it's determining convergence. Okay, so if 1, these are the 2 conditions that need to be met. So 1, a sub n plus 1 must be less than or equal to a sub n for all, that upside down a means for all n, after a certain n. Now, it basically just means that the terms are never increasing in absolute value. Okay. And then number 2, second condition, is that the limit as n approaches infinity of a sub n is equal to 0. Okay, so we're going to determine the convergence or divergence of these 2 alternating series. So let me show you what we need to show, because you do have to meet those 2 conditions that I labeled as 1 and 2. So the first thing that we want to do is we're actually looking at a sub n, which is 1 over n. That's the non-alternating part. So number 1, we can take the limit as n approaches infinity of 1 over n, which equals 0. and that satisfies the second condition, right? The limit of as n approaches infinity of a sub n does equal 0. Check. Okay, number 2 is we need to show that a sub n plus 1 is less than or equal to a sub n for all n after a certain n. Well, we do know that a sub n, which equals 1 over n, is decreasing on the interval from 1 to infinity, right? As I'm plugging in values. So therefore, a sub n plus 1 is less than or equal to a sub n for all n on our interval from 1 to infinity. So check. That second condition is met. And so therefore, what we can say is the sum from n equals 1 to infinity of negative 1 to the n plus 1 times 1 over n converges. And a lot of times they'll abbreviate alternating series test as AST, by AST. Okay, go ahead and pause and try number 2 first, then you can unpause, and we can do this one together. Okay, so we're gonna look at a sub n first, which is n plus 1 over n. Okay, so the first thing that we need to do is I'm gonna take the limit as n approaches infinity of n plus 1 over n. Well, that actually equals 1. That does not equal 0. So what does that mean? Well, if you remember way back when we had the test for divergence called the nth term test, and that test stated that if the limit as n approaches infinity of your a sub n does not equal 0, it actually means that it diverges by the nth term test. So therefore, we can say the sum from n equals 1 to infinity of negative 1 to the n plus 1 times n plus 1 over n diverges by the nth term test. Okay, so the last thing that are on these notes is actually for you to fill in the tests that we've done so far in the lessons. So there's only 3 that we've done so far. So the first one we did was the nth term test. We also did the geometric series test. And then this one is the alternating series test for convergence. And so go ahead on my website. There's a nice summary that you can fill in this box on mrsfitzmath.com. And it is a great resource just to have that there for you to reference for just the 3 tests we've done so far. We're going to add plenty more as we go along, so keep that in mind. Okay, thank you and goodbye.